Glad to have everybody with us, whether it's morning, afternoon, evening, wherever you're joining us from. We're going to talk a little bit about Reactor, the framework. Just went 1.0 release here recently, and so we thought it would be a good idea to have another update to kind of talk about, what's in the release, if there's any, updated information, about the APIs or anything like that. And then I kind of included in this some content of, maybe answers to some questions that I've gotten or comments that have been made, on Twitter, or, when I talk to people in conferences or whatever, some questions that they've asked. So I'll try and address some of those things that have come up as we go along. The subtitle here, Foundational Framework for Reactive Fast Data Applications. I want to talk about all those topics. I want to talk about how Reactor is foundational, what that means, why that's different than just a normal framework. I want to talk a little bit about reactive programming, what that means, how Reactor is reactive, and then, of course, fast data is a kind of a catch-all like big data. So anymore, it can't just be big. It has to be fast as well, because big is good, but if there's too much of it to do anything with it in a reasonable time frame, then it doesn't matter anyway. And so then we included the JVM there to differentiate from just Java. So this is a framework, obviously, in Java. But there are language helpers and things for Groovy. There's a library for Clojure. In the earlier webinar, some people asked about Scala support. So there's all kinds of possibilities for the JVM developer that we can explore here with a very succinct and open API like what Reactor has. So what is it? Foundational library. So by foundational, we kind of mean you may not necessarily expose the bits and pieces of what you write using Reactor to an end user. And by that I mean if you write a Spring application or you write a library, for internal use or internal users, and you use the Spring framework, it's more than likely that the user of your component will also be using the Spring framework because it's included and it's kind of goes with it. So in that sense, you're using the same abstractions that the library is using. That could certainly be the case with a Reactor application. You could write it that way, but sometimes it seems like it makes more sense to have a foundational part that's kind of removed a little bit from your domain problem. So you might have APIs, design, and interfaces, and classes and whatnot with methods that don't have anything to do with Reactor, and don't expose Reactor abstractions, don't take consumers, don't use some of this other stuff. You might do that. That's certainly an option, but probably the best the best option is going to be kind of a mix. It's kind of a gray area here between the user level and the lower level abstraction. So by user level, we mean those things that the user is going to interface with. So kind of what seems to make a lot of sense is have core Reactor components in your API and underneath, in your methods that you use to communicate events around within your application, and then maybe expose some abstractions to the user. So in that, you maybe return a promise so that the user can set on success on error handlers. You may accept a consumer. So a consumer is just an interface with a single method so that it can be very Lambda friendly. It comes from JDK 8. We've pulled inspiration from there. We basically just kind of said what is coming in JDK 8, and we copied those interfaces in so that we could use those and when JDK 8 becomes readily available. So there's going to be a gray area. There's not a right answer to this of how much Reactor to expose. How much do I use? You can use it just like the Spring framework, and the user would use any and all abstractions from Reactor that they want to, and then they would interface with your library or your component, which is also using Reactor, and they would be seen as peers of one another. That's perfectly legitimate. So if there's a gray area there, there's no easy answer. It just depends on the problem that you're solving. You think about it as like application core. So you'd write certain parts of your application, the core part of your application, maybe that is responsible for dispatching events and things like that. You would write it using Reactor. and that's kind of the area that you would focus on. And then you might have other libraries that you're using that you would kind of mix in and expose certain things to the user that way, or you would use the Spring framework and expose certain things that way. So that's kind of where we see Reactor fitting in the scope of things. You could write drivers. You could write most servers anymore. I mean, you take a look at Couchbase, which I'm going to use an example of. It uses a memcached protocol. You look at Redis. You can use the like say Lettuce driver or something like that, but basically Redis implements just a very simple protocol that you could actually implement yourself. And I'm kind of I've looked at that a little bit of what would it be like to create a Reactor-based Redis driver, which had all of the promises and consumers and all that sort of stuff. Not very difficult. Just have to spend time doing it. But that's probably a good example of where a Reactor component would fit into your invented application. Because a lot of times when you're dealing with events, you're dealing with them at a fairly low level. When you're exposing things to users, you probably want a little higher level. So you might rely on some other abstractions for what you send out to the users and what you expose to the users, and that's where those kind of data integration libraries, that's kind of just a catch-all word. Could use Spring integration, capital S, capital I. You could use Spring, capital S, just integration, and use the Spring framework itself. So there's various ways to go about, putting Reactor in the right place in the architecture and how it interacts with other parts of your application. So one of the things that maybe gets a little confused sometimes is Reactor, actor model? Does it, is it reactor? Is it proactor? What are these various patterns and libraries that we've kind of drawn inspiration from? Well, it's not easy to answer. Basically, we've distilled, if you will, the best of what we like out of these other libraries, out of these other patterns, best practices, whatever term you want to use. So there's certain things about the actor model that we like. So we've tried to look at that and say, okay, what about the actor model do we like? We like being able to register a component, send it a message, have that complete disconnect of basically it's just event-driven application. Here's a key topic, whatever you want to call it. Here's an event, it's got data in it, maybe it has metadata. Go do it. And so that we like that part of the actor model. But then we also like some of the other patterns too. So we don't want to implement an opinionated one, and maybe that's a jack of all trades, master of none. That's up for your interpretation and argue that over a couple of beers. But the core of it is that we're trying to distill down into a succinct, usable, understandable library. A lot of the best practices that have kind of surfaced from different different libraries, different thought, at work in academia. All of these things kind of have come together. So what people will sometimes criticize Reactor of is well, it's not this, it's not that, and I mean, if you want to look at it as a criticism, we would have to say, okay, fine, that's true. We don't look at it like that. We look at it like it's not supposed to implement all of the Reactor pattern. It's not supposed to implement actors, like you may recognize them exactly from other things. It's meant to be, and whether we achieve this or not, up to for interpretation. It's meant to be, kind of best practices that make it easy to get involved in that, make it easy to utilize the good parts without necessarily taking on, baggage that you don't always want. So that's kind of where Reactor's coming from in the landscape. Expect to see elements of these other patterns. Expect to really, before you can really make use of the abstractions in Reactor, expect to kind of have to understand what some of these other patterns or other inspiration is. Be familiar with Java 8. What are some of the Stream API and things like that they're introducing. Read up on the actor model and things like that. And that will kind of all mix in together and give you not an idea about how Reactor works specifically, but that will give you an idea of, okay, this is the area that we're working in. So we're getting little bits here, we're getting little bits there, and we're combining them. So Reactor itself does not have a dependency on Spring. It's only hard dependencies are FLF or J for logging and the LMAX Disruptor RingBuffer. We could probably technically make the RingBuffer optional, but it's really kind of a fundamental component that you're probably going to rely on a lot. So we just decided to make it a hard dependency. But it's that low level of a library. The other integration that we have, the other libraries that work with Spring and Groovy and some of this other stuff are optional modules that you can add in. So we don't depend on Spring. There's elements of Spring that depend on Reactor. It's kind of the other relationship. That's why you see it in this new Spring I/O platform. If you've heard about that, a little bit of a architecture diagram here. But this is what this is where Reactor fits. It's in the core foundational layer. It's alongside Groovy, which obviously is language, but still it's a core component. It's a foundational component. It's alongside the Spring framework. There is integration between the two, so you can move between the two worlds easily. But you don't have to use Spring to use Reactor. Reactor will work on its own. It will work in Java 6, 7, or 8 if you want to use it. The demos I'm showing you are going to be using Java 8 because I like lambdas. I think they're cool. I think we need to, I want you to be exposed to that a little bit, so I want to show that. But it's not at all a requirement. It just makes for demos a little bit more succinct. So a little bit more detail here on what makes up Reactor and how it all fits together. We've got like I said, the core component you'll see in there, the Reactor core part of it that doesn't have a dependency on Spring. That's the stuff that you need to write any bit of event-driven widget of any sort of component, an application, whatever. The other things around it, Reactor Spring, Reactor Groovy, Reactor TCP, they all depend then on core and then extend that functionality into the particular problem domain. So looking at Reactor TCP, for example, we've got abstractions in there where you can write a TCP server. Now, Netty 4 is a first implementation of that, but it doesn't have to be the only implementation. So we're not hard-coded into rely on Netty. It's a great library. It's a very logical choice. Almost nearly ubiquitous in the industry. So it's a great place to start. But there's also 0MQ that we could look at, and I've done some work along that line to see what is a 0MQ backed Reactor TCP setup look like, and it's actually pretty cool and pretty initial testing anyway shows that it to be pretty performant. So that's something that we can do there and extend. We could write a traditional Java JDK BIO implementation of Reactor TCP if we wanted to. Wouldn't make a lot of sense using blocking and async, but the point of it is that it's pluggable in there. And then on the other side, the Reactor Spring stuff kind of brings in application context goodies so that we can work with reactors in the environment in Spring application. We can get things injected that we don't have to worry about creating ourselves. We get a few annotations that we can put on, use a POJO, extend the POJO model a little bit, and use annotations rather than doing direct wiring of method calls if we choose to do that. I'll show a little bit of that in the demo. So we mentioned reactive programming, and that's kind of a buzzword that you're going to hear quite a bit, so I wanted to mention it and kind of put that out there in the discussion. So I thought this definition from Coursera's description of reactive programming for their course, the reactive programming course, is really good. So, they say reactive programming can be seen as a natural extension of higher order functional programming. So we've got some of the functional programming concepts in Reactor, the abstractions that we lifted from JDK 8, consumer, supplier, predicate, function, things like that. So those are the functional programming aspects. and then 2 concurrent systems that deal with distributed state by coordinating and orchestrating asynchronous data streams exchanged by actors. And so they use the word actors there, and so we might not necessarily use a word with that kind of connotation. I might use just generic component, but an actor is a good description of what it is. Not capital A actor, but it is some form of component that receives a message and does work, and in that sense it is an actor. So some of these terms are a little loaded. Maybe that's part of the confusion. But I thought that was a pretty good description of reactive programming in general. There's different implementations of it, and kind of it comes from reactive extensions in .NET. Really a good place to start if you want to learn, just kind of what is reactive programming to begin with. And then that then in turn led to Netflix's RxJava being kind of a good place to start for how do I get reactive programming into the Java world. So that's where Reactor kind of gets a lot of inspiration as to how RxJava uses observable and how you can respond to events. You can compose actions on things. You can also do that in the JDK8 Stream API. So we definitely get a lot of inspiration from there, and we've also kind of looked at what is maybe integration between RxJava and Reactor look like. If you create an observable and be able to dispatch tasks and things into a Reactor kind of transparently and work between the two worlds, where events coming into a Reactor could then be dealt with using the RxJava API for composability and things like that. There's lots of synergy between the two. There may be a little overlap in some higher level areas, but basically I'm thinking RxJava and Reactor could work very well together, both kind of working in the same reactive programming arena, both doing it, coming at it maybe from a different perspective a little bit, and dealing with different issues in a slightly different way, but still in a very compatible way with one another. And then the observer pattern, is pretty simple, reacting to events rather than being have a method call and pass data, and then return a response, and it's very traditional programming. Unfortunately, that's a lot easier to understand when you're reading the code than the event-driven code is, which oftentimes is disconnected from one another. So there's no obvious flow from one component to the next, whereas if you're reading code and you're calling methods, hopefully the methods are named reasonably so that it's somewhat self-documenting. You can see there's a return value coming back and what happens with that, and so you can kind of follow the logic of it. Hopefully the programmer put some logic into it so it's easy to follow, which we know is not always the case. But at least there's a little bit of documentation in the code itself. What seems to happen sometimes with reactive programming, asynchronous programming, whatever you want to call it, these event-driven libraries, is things get disconnected from one another. You have one component over here that gets bootstrapped in some way, and then it receives events, and they may be by a key rather than a method call. So there's no direct link. That's just a consequence of it being asynchronous and having the very flexible environment to work in of having it event driven. That's just a byproduct of that. So just something to keep in mind. It does make it sometimes harder to debug. That there's not a whole lot that you can do about that in an asynchronous program, but Reactor tries to do what it can to help you deal with these different components as they're being wired together, and that's where the Stream and the Promise API come in, which hopefully we'll show in a little bit here. So how is Reactor then reactive? How does it do reactive programming? And so the idea is basically that a reactor, which is an object, it's an abstraction inside the Reactor framework, can route events based on a selector. So a selector is the left-hand side of an equation that says, that here's a criteria that I'm matching against object X, right? So could be a string. I could create an object selector based on a string, and then when I do a notify, I just send the string. And so I'm using a topic that way. I'm doing kind of pub/sub type messaging if I'm using a topic. I could also use just an anonymous object. So in cases where I'm writing APIs and I'm writing libraries that I need to have somewhat exclusive access to a topic, I don't want to have it an easily found string, coded into the hard-coded and put out there on GitHub. I want a scoped object that I've created that only, I can respond to. And so then you would create an anonymous object, and you could use anything. You could say, just new object if you wanted to. And then you would use that as a key and maybe set that as the reply to, and that would allow you to create kind of dynamic bindings, if you will. You would be able to create dynamic topics. If you want to create a UUID, for example, that's a good way to create just a kind of random, pseudo-random operation ID, if you will, and create a UUID and register it on using a selector, and then say, hey, here's the one you want to notify when it's done. And then other code can't just arbitrarily send messages to that consumer, which could be a problem depending on what your consumer is doing. In some cases, and probably in a lot of cases when you're using Reactor, you're probably going to want to set up certain things that are known topics, if you will. So like if you want data to be saved, then you would set up maybe a URI type selector that says store ID, just like you would if you were posting to an HTTP address, right? Or maybe you wanted to use a regular expression and you wanted to use dot-separated topics and do a capture group on one and extract data from that. You could do that. There's different kinds of selectors that you can use, and there's a couple of examples there. The regular expression with capture group with the URI templating, so you can extract data. And selectors are very powerful in that way. We have a class selector, which is how we notify a lot of errors. When we notify on a Reactor, we use the class of the exception so that you can do kind of hierarchical handling of exceptions. There's an optional JSON path selector, which can interrogate the key object, and you can put a JSON path filter in there to interrogate what's coming in. And you could create your own selector based on an arbitrary predicate, so that you can use any kind of information to decide whether or not this consumer should be invoked with the given data. So hopefully you can kind of see how we're mixing some of these patterns. If you wanted to create like an actor, then you could create an ID, like I said, a UUID. You would create an object, and you would just register it on the Reactor using a selector, and you would have an actor in there that you could send messages to. So anytime you want to send messages to the actor, then you would notify, and give it the UUID and then the data. Now, that's not the full actor pattern. That's what we talked about earlier. We're not trying to implement the full actor pattern, but that's the part of the actor model that we like, and that works really well in certain for certain things. I do want to mention about the $sign there, which is a helper method. It's not the only way to create a selector. There's a little confusion on that. Each one of these one-letter helper methods are really designed to be absolutely as succinct as possible. So when you're writing code and you're creating selectors in your code, we want no more letters than is necessary to perform what it is you're trying to perform. So when we're creating selectors, we have these methods, these static methods, which is what these are, and you can't get any more succinct than a single character. So we kind of looked around at what character could we use to represent a selector. And if being familiar with jQuery, if you've ever done any JavaScript in jQuery, the $sign right off the bat It does other things in jQuery, but it does a selector, a CSS selector in that case, but in this case, it's an object selector. Kind of freaks people out because sometimes they don't even realize you can use $ as method name. Not something I would necessarily promote as a general practice of creating $ methods, but in this case, trying to be succinct, trying to be recognizable so that when you're reading code, it's clear what's going on. So even though you don't have a method name spelled out here, if you see the $, you immediately know what's going on here. You're creating a selector. If you see the R, conversely, you know, hey, I'm creating a regex selector. I could also use the long form, or I could create a new regex selector. It's kind of up to your programming style and how you want to go about it, but this is recognizable, this is succinct, and this is one of the goals of Reactor. So I wanted to mention that because there's different people react to the $ differently, and it's kind of to each their own type of thing. If you don't like the $, that's fine. There's alternatives to it. Pretend like it's not there in the demos and whatnot. You can use the alternatives if you want. You're not locked into it. So the code to create reactors can be used, as I said, outside of Spring. The demos are going to show you Spring Boot and some other cool stuff that we can do with Spring. But here is what it looks like. You just, like say, from a Java main or from a test or something like that. The environment is kind of important. It's where the dispatchers are created, and a dispatcher is a way for consumers to be run. It provides a thread on which that consumer will be executed, and it does it differently depending on the dispatcher implementation. So we've got the RingBuffer dispatcher, which uses the RingBuffer to allocate a slot and stick the task in there, and then it's executed on the RingBuffer thread. And then we've got an event loop dispatcher. We've got several of those created in the environment so that every time you get one, it kind of load balances across those that are created. And the event loop dispatcher is just basically like a blocking queue with a thread that pulls stuff off and executes it as it gets it. So it's very simple in that regard. There's a thread pool executor dispatcher. So when you're doing I/O tasks that have to reach across the network and things like that, you probably want to use the thread pool executor. Synchronous executor for when you're working inside an event, for especially inside the RingBuffer. If you're already inside the RingBuffer thread, you can't then go out and try and allocate another slot. It's kind of a recursive dispatching type thing. So you'll need to use the synchronous dispatcher in that case. Lots of big topic really for dispatchers and how threads are managed and how best to do that. But that's just kind of the 30,000-foot level. We could definitely get into some more discussion on that. If you want to send us some emails, join the mailing list, or send us a tweet or something like that, and we can provide some more information on that. So to subscribe then to events, we need a selector, as I mentioned before, and we're going to use the on method here. Now, the little bit of noise there with the generic signature, but that's basically, since we're using lambdas, we have to put the generics in there to tell the EV of the lambda what type it is. Otherwise, we'd have to do a more traditional parameter block with the type before the variable name. Either or, but this is a lambda here with the little arrow. So we've got our selector that says, hey, anytime I get a key of test, which is just a string of test, then run this consumer, which we could replace this lambda with a new consumer event string if we wanted to, if we're using Java 6 or 7. But this is so succinct, I just think it looks cool to demo. Hey, this is what we're going to be able to use in Java 8, and we're ready for it. Not required, but certainly Reactor is designed to be ready for Java 8 when you are. So the other side of that, the producer side, it used the notify method, and so our selector said match on this string test. So there wasn't a lot of dynamism or anything like that involved. It wouldn't match more than one key, and in this case, we're sending the string test. So it's only going to match on that one object, the object test. Obviously, if we use a different type of selector there, we could do test dot and, a capture group of some sort, dot plus, and for a regular expression, and then it would match any test dot whatever. So, that's how you would kind of match. One selector matches multiple keys type, in a traditional like messaging environment. And then everything is events in a raw reactor. So we do want to wrap that data rather than you just publishing an event, a raw data point of some sort. You're going to publish it inside an event because an event has metadata, optional metadata associated with it, headers, and there's various things that you can do with events. So that's your basic interaction. You've got what to do when this is kind of a traditional callback mechanism, and then notify and then send the data. So then you build on that, and we have a send and receive, which is kind of the next step up, if you will. So we can still use selectors. We can use any selector we want, and so we're going to say, whenever we get this topic coming in, this time we're using a function rather than a consumer, which the Lambda was actually a consumer previously. So we're going to take an event, we're going to do something with it, and then we're going to return an object that should be considered the response. So when we publish this event in the send method, so we say send and then test2, that will match our topic so that it goes into the function, we say set reply to test. And so we had that from the previous slide, a subscriber on test, and so we're saying what we want to do is publish into this function, we want to do work, and then whatever comes back out of this function, we want to send on to the notification key test. And so that's a way to do request reply asynchronously. There's no blocking involved here. I mean, this just basically it runs it in your thread. So if you're doing I/O, then you probably want to have a thread pool dispatcher, and then it goes back to another consumer, or could be another receive, which returns a different object. So you can see how that you might be chaining actions together, since really all you're doing is sending a message to a topic. It's very easy to do. So fastdata and the hashtag uberfastdata, I'm trying to camp on that just because it's Uber everything is really kind of what we're looking at with Reactor. We're trying to be uber fast. We're trying to be uber high throughput. And so these numbers here, 10 to 15 million per second with the selectors, which is dynamic dispatch, which is a regular expression, URI template, things like that. The RingBuffer processor, which is just a thin abstraction around the RingBuffer itself, can do 100 million per second, and so that is obviously not like real world application throughput, right? That is really basically not doing anything. Just how fast can we push events through? Now, what you're going to do in your consumers and your functions and things like that is going to slow that down. Now, how much you slow it down, is kind of part of how you build your application and profile it, and decide, hey, maybe I don't want to deal with buffers quite so much. Don't copy them. Maybe I need to reuse things. Maybe I need to pool. There's various things that are going to go into this as you try and get more and more and more throughput. But the idea is that as far as possible, Reactor wants to do things so fast that you're never going to be able to overtake the library. That the work that you do is always going to be slower than what the maximum throughput of the library itself can handle, so that we're not in your way. Because that's the ultimate point, is that we don't want a library that gets in your way and introduces overhead and makes things less efficient by just the mere, production and publication of events and, wiring things together. As fast as possible, we want to let you get your events through the system and out, and we don't want to be introducing any overhead to do that. And so that's what those numbers represent, is, Reactor getting out of the way. What you do in there, doing I/O, reading from buffers, mapping from, byte to object, those sorts of operations are going to require CPU cycles, and that's fine. That's those guts of your application. That's what you're doing. That's what you're building it for. Don't expect 15 million operations per second if you're going to map a big chunk of JSON onto an object, right? I mean, it's just not realistic. But know that you can do that operation and dispatch it dynamically using selectors, and you're still probably going to get millions if you do it right, and you're using maybe Jackson and certain sorts of things that that you can get high throughput out of. Even if you only get 500,000, 600,000, 700,000 per second, that really is a lot when you start spreading it out. Of course, don't block is the thing that when you're dealing with like event loops and things like that. If you're going to get low latency, you can't block the thread that other events are waiting on, right? So you can't go do I/O in the RingBuffer. You can't do an HTTP request to a slow server, right? Because you're going to be blocking everyone else from getting a slot. So you want to make sure that whatever you do in especially the RingBuffer dispatcher and in those consumers is done kind of in memory. You interrogate things. If you want to read data out, do it as efficiently as possible, but don't block and do blocking I/O and wait on things to happen. That's the fundamental part of getting high throughput in asynchronous application. The real thing, more than the getting 10 million per second, 100 million per second, whatever, that's all well and good. But what can you get per minute, per day? That's more important to your application, right? Because you're probably going to be thinking in terms of multiple seconds and multiple minutes, over a period of time. How fast can I push stuff through? That's probably going to be a more important metric, and that's where you're really going to be looking at the greatest benefit over whatever it is that you're doing today, because hopefully Reactor is going to give you a higher throughput because of a more efficiency, which that's the goal. So dispatchers, as I mentioned, are a way to do task execution. There's various kinds of them. The thread pool executor is basically what you'll want to use for I/O, which I'll show you in the demo. And then these other ones are more. You have to use them more carefully. So the blocking queue dispatcher is almost one you could use indiscriminately, like a thread pool executor. The only thing you might have to keep in mind is you're going to be using a single thread. So whenever you get a Reactor with a blocking queue dispatcher, event loop style dispatcher, you're going to be getting a single thread. So every event you post to that particular Reactor is going to go through the same thread. Now, that may be what you want because you may be doing transactional things. You may need, thread locals and things like that. So, that may be the dispatcher that you need to use, and then you're guaranteed to get a single thread in that. You're going to get a single thread with a RingBuffer dispatcher. That's just the way it's set up to work. It's not, we don't use the worker pool or anything. It's basically a single thread. But it's so fast that that's okay because you run as much stuff through as possible. There's no context switching overhead. And, we've benchmarked this thing of, 27 million different ways. And I can just tell you from experience that if you do a relatively small batch in the processor and you're using the RingBuffer, a single thread is going to get you higher throughput than if you don't use a single thread because the way that's scheduled on the CPU and the overhead involved in thread context switching and whatnot can really be quite noticeable when you're doing kind of micro benchmarks. You probably don't notice it otherwise, but when you're doing micro benchmarks and you're kind of parsing milliseconds and things like that, then you start to see how that kind of stuff can affect your throughput. So generally, I would say probably less is more. So that's why we start with the number of processors in your machine being the number of threads you're going to work with in these thread pool executors and event loop whatnot, and then a single thread for the default configuration of RingBuffer. You can create more than them, more if you want. But like I said, when you start using multiple ones, you're actually going to start seeing a lower throughput than if you just use the single thread one. So. There's the long form of the selector, and it's really important to understand how selectors, can be used. You can extract data from them. So you can use a URI, and like you were doing a Spring MVC application, you can do path and segment and extract that data as headers in your consumer. And then the predicate selector is a special kind of selector, which basically is just an open-ended predicate. It just takes, you implement the predicate interface, and then, kind of jokingly, I put the position of the International Space Station. If you had access to that information and you had a consumer registered on a reactor and you sent an event in, you could check to see, well, if the space station is in a certain position in the sky, then this consumer matches. That's a very powerful feature, and, really consider how you can use that. You might create a selector, custom selector implementation that takes into account data from your problem domain, like whether a resource exists or whether a server is up or whether I am running on the AWS or whether I'm running in a test, on a test laptop, or you can see where some of this stuff could really be useful. You could have multiple consumers using different selectors that are based on different criteria, and so that's the real power of the selector. It's more than just a topic. Topics are useful and they're easy to demo, and I'm going to be showing URI template selectors, so that's kind of the next step up in functionality. But really, if you start digging into like predicate selectors and maybe your own selector implementations, you're going to start seeing a lot less code to deal with, who goes where, because now that's encapsulated. The decision of where to send a piece of data is encapsulated inside the selector implementation. That's a logical place to put it, and that's a single point that you can go to, easily documented and easy to understand when you're reading the application. So then building on top of Reactor Core are what we call the composables, and streams are one of the composables. They're stateless, open-ended, no beginning, no end. They just deal with data as it comes through. There's some batching that we can do on them, so there is a start and the beginning of the batches. But other than that, they're basically stateless. Values just pass through them. They're used for composing functions rather than setting, callbacks and on using selectors and things like that. We kind of use that internally. We use Reactor and selectors and things to do this, but then what we expose to the user is functions like map and filter, and very similar to ArcsJava's observable, the JDK8 stream. Now, if you look at the JDK8 stream, you'll see a lot more complicated API, but still something that we used as an inspiration of how to react to data coming through. So just as a quick example, we've got a stream here that we're taking in a string, and so we're using a Java 8 method reference. So rather than creating an anonymous inner classes, we'd have to do a 6 and 7, which we could easily do because Reactor goes is 6 and 7 compatible. But with Java 8, it's compressed all the way down into this very succinct statement, this string : to uppercase, this method reference. That's pretty cool. That's why I wanted to demonstrate that. Next line, filter. So we transform the string coming in to uppercase. All of that method reference is basically takes the place of an anonymous inner class, accepts a string, does it to uppercase, and returns it, blah, blah, blah. So you can see how much more succinct that is. Filter, simple predicate test, check it for first letter or whatever. Again, we check anything we want. Only data that passes the predicate then goes on to the next consumer, which is just a simple consumption, takes a string, logs it out. So we could chain a bunch of these functions together if we wanted to. We had a whole series of things that had to happen. We had to transform it from one form to the next. We could create a stream that initially took a long as an ID and returned a object. And then in the next map function from that, we could say map object to another object, or extract a piece of data and then filter it and then consume it and do something with it. So you can see all non-blocking, all asynchronous, connected together, that you don't have to do complicated wiring of creating your own selector, anonymous object things. We take care of all that for you underneath the covers. All you have to worry about is just map, filter, consume, etc. Promises are very similar. They're descended from the same hierarchy. We call them the composables. So they have a little bit. It has the same API for several functions, map and consume and things like that. But promises are stateful. So we don't have some of the more stateless stream-oriented functions on promise. We also kind of looked to the promises A+ spec, which is actually a JavaScript spec for describing a promise API. We kind of looked at it as a good example of how to put together a promise. So even though the kind of initial inspiration is coming from the JavaScript world, this is this is the Java API for a promise, and it allows you to do this traditional callback style, on success, on failure, on complete. A promise, as I said, is stateful, and it has either it's either incomplete, in success, or in failure. So you get one of those states, and you can only complete it once. So a promise represents a value. If you want more than one value, then you need to deal with the stream. But if you want a value, and you even need to block on it, because a promise is like a future in that it has an await method on it where you can actually block the caller if you need to do that, or you can deal with it asynchronously. And then of course it has the map function on it so that when the promise gets completed, then you can do transformations on it and consume it and things like that. One of the things that's a little different with promise than with stream, and it kind of when you get to using it in your API, you're going to come up against this issue. A promise will execute the handlers that have been, if you set an on-success handler and then you set the value later, obviously it's going to trigger the on-success method when it gets the value. That's the whole idea of deferring, delaying a value. But the inverse is also true. If you set a value inside a promise, and then later you set the on-success handler will be run immediately with the value of the promise that's been fulfilled. We can do that with a promise because it's stateful. We know the value. We know that it's been completed. With a stream, we don't know that. So if a value has already passed through a stream, when you go to set a map or whatever on a stream later, you don't get the value. It's already passed through. That could be an issue depending on how you do your API. If you, for example, create a stream and then immediately submit a job to run and then return the stream to the caller, it could very well be that job is run in another thread and complete before the user has had a chance to set their handlers and things like that on it. So there's a little bit of, you have awareness there that you have to, realize that these are two different things. They share the same API, but they kind of function differently, stateless versus stateful. So the processor, as I mentioned, is really just a thin wrapper around the RingBuffer. The idea was to get the LMAX Disruptor RingBuffer, use it as efficiently as possible. So rather than use it through the dispatcher abstraction, in this case we're using it pretty much directly. I mean, all we've done here really is provide Reactor-specific APIs to integrate with the RingBuffer. So rather than using the RingBuffer directly and setting, event handlers and things like that, you're using consumer and supplier, and you're using this operation. So it works in the same way as when you're working with the RingBuffer. The prepare is like, allocate the next slot. Then you want to the get. An operation is a supplier, and you see there the buffer is the data that's being, has been pre-allocated in the RingBuffer. So we get the data out of the operation and we put data in it. And then we commit, which means basically do a publish. And so we can do that individually, with one slot at a time, and that might be necessary depending on how the API is set up. But if we know that we're going to be processing, a certain amount of data, and we know that ahead of time, then we can batch them, and that's way more efficient. If we can, in this instance, 512, if we can go through and queue up basically 512 operations at once, then before the call returns here of batch, it's going to go through and do a batch publish, which in the Disruptor RingBuffer is basically, publish 1 through 512 all at once. Everything goes out. That's a much more efficient way to publish everything than individually, less overhead, things like that. So two different ways to do the same thing, but depending on your throughput needs and whatnot, that's a good way to use the RingBuffer directly without the selection overhead, and using a reactor and kind of the indirection that happens as a result of selectors. Spring integration, which is an optional component, basically allows you to put an annotation on your configuration that says, hey, create an environment for me, I'll use it everywhere else. There's some other goodies that it puts in your application context whenever you do enable Reactor, which I'll show here in a minute. But that's just really kind of a convenience for you to basically use the Reactor API to create reactors and have them injected into your beans and whatnot. So what's really kind of the big Spring flavored Reactor integration is the fact that you can create on your beans methods, and you can annotate them with selector annotation, and you can say, hey, when this key happens, execute this method. And so that's a way so that you don't have to have references, directly to these beans and place them as consumers and use anonymous consumers and things like that. You can you can use the Pojo method. You can just place annotations on it, and it's loosely connected. It's just found in the application context as a normal part of normal component scanning, and it gets wired together for you. That may not necessarily be what you want in all cases. Like I said, part of the downside of asynchronous programming is that it's not always clear what component happens. But you're reading this and you say, okay, when a certain topic happens, I run this. I know that. Now, what triggers that? Well, it could be any number of things could actually trigger that. It doesn't tell you from reading this, but that's kind of one of the benefits of it. It is a separation. It is a meaningful separation between the publisher of an event and the consumer of the event. So this is the consumer side. You would publish into the Reactor, probably using the Notify, because you would be reading in data, maybe from a TCP server or from a WebMVC controller or something. You would be acquiring data in some way and then publishing it into the Reactor, and then your Spring handlers then would kick in. So if we look at that real quickly and take a look at what some example code would look like, I'm going to be using just a simple Maven project, but I'm going to be using Spring Boot. So if you're not familiar with Spring Boot, you should really look it up. It's a great way to get started very quickly. It takes care of a lot of the stuff that you're going to have to generally do in every application anyway, or every project that you're getting started. Here I'm just going to set as my parent the Spring Boot starter parent, which pulls in lots of properties, lots of stuff that I won't have to specify then myself. And so I'll show you the annotation that kind of triggers this. But basically, we're just going to pull in the Spring. We've got the couch-based client. We got Jackson for JSON processing and stuff, and some testing. So nothing fancy, nothing nothing earth-shattering here. Just a very simple Maven project. And so one of the nice things about Boot is that we can create just a Java main, and we basically have this static method. We can say, hey, run this test, and that's this test right here. It's not really a test class, but it's just a name. It could be anything. But the important part is the @enable auto configuration, which tells Boot, hey, I'm going to be creating an application, and I don't want to necessarily have to specify everything you need to create for me based on what I have included in my class path, and maybe I include Spring Data, and there's starters for that kind of bootstrap stuff for you automatically. You can override things and tweak the configuration. Of course, it's not generating anything for you. It's just standard stuff that you would include anyway. And then basically, depending on how your application is structured, then Boot is smart enough to figure out what's going on and then create the right things for you. So the only thing you end up needing to, in this case, I've got enable Reactor, so I have my environment created for me for doing a Reactor stuff, is that I just put the component scan on here. And this is just really for illustration of creating some beans. I've got an object mapper, from Jackson for doing the conversion. I've got a Reactor that I create using the thread pool dispatcher. Here's a helper method that we've got that takes a couple different parameters. The environment is the important part. That, like I said before, you want to use one of those and not, and not be creating those all the time. And I've got my couch-based client for persisting data. Nothing fancy. We're just going to bootstrap whatever we find in the environment. So we want to create a component, and we've got a bean here with the component annotation, so it'll be found. We're going to take our couch-based client and our object mapper, and what we want to do is accept. We want to accept an event of a person, and we want to store it as a document. And so the way we can do that really is we create a method on our bean here that says, okay, we know that the way we're going to structure this application is we're going to send a notification to a key. So we're going to use our selector annotation, and we're going to say, let's use the URL scheme. So we're going to say store ID. Right? The type of this is going to be the URI template selector, and then our reactor that we're going to be dealing with all of our events on is going to be the one that we created in our application context. So this basically is very simple. It just says, hey, we're going to send us to a topic, and we're using a URI structure here, and then this is going to match any /store/ whatever, and we'll be able to extract the ID. So since we know that it's going to be in a header, we can pull that out from my event, get headers, get ID. So that will give me the ID that we used when we notified that, and then we want to store this in our persistence engine. That's ID, and we want to store it as JSON, and basically we just want to get the data out of it. Signature, and then we're just going to return. That as a reply. So whatever object we return here is going to be sent as a reply. Since we are sending something back, we need the additional annotation of the reply to tell it, hey, this is going to be sent as a reply. Otherwise, it just is a one-way street. Comes in, and basically is like a void method. So that's all that we really need to do to have a component that anybody can send data to and have it stored for us in the persistence engine of choice. And of course, since this is abstracted away, now this person reactor could accept a person and store it in anything, or it could send a message, or it could cache it, or you could see that you could just basically swap this out because anything that responds to this, or everything that responds to that, will be dealing with that event. So what I need to do now actually is create a public API. So I don't want to expose the fact that I'm using Reactor events underneath. I don't want to expose how the threading is working and whatnot. I just want to provide a component that I can inject into my user code, a service that it can call as a method and asynchronously still work with what's going to happen over in the I/O threads. So I want to create a save method, and I want to return a promise. Now, the way you create a promise in Reactor is you actually create the producer, the thing that's going to put the value in the promise first, because that's how you're going to notify the promise that a value is created. We call that a deferred because you're deferring value. So I'm going to defer the person value, and I'm going to create a promise out of it. You can do the same with streams. Basically, create a deferred person. I would just replace stream here and get the same thing. Promises.defer, and I'm going to use my environment that I have injected here, and let's use the RingBuffer dispatcher just for giggles. So we know that we want to return the promise to the user. So we don't want the user to be able to publish values into the promise. We want to control that. So we'll keep a reference to the deferred, but what we will return to the user is the promise, which we get from the compose method. So that kind of tells the deferred, hey, give me the composable so that I can start adding handlers to it and whatnot. So that gets our promise created and deferred created. So we have to actually trigger it. Now we have to actually tell the actor, if you will, the component, hey, we need to save this person. So I'm going to create just a unique ID. I want to say that every time we call this, we're going to save a new one. So we'll use a simple UUID. The UUID utils comes from Reactor. We've got we do create time-based UUIDs, so they're real fast to create, real efficient. As you probably have found out, if you use UUIDs, the standard JDK generation is extremely slow and will kill your throughput. So don't use it. Use a time-based UUID or some other kind of random or some other kind of generator of some sort. So we know that what the actor that's responding actually is listening on the store / whatever, right? And it needs to take the person object. One thing that we can do is we notice that if you remember, we're returning data here. We've got a reply to, so we can actually do something with the results of the function. So we want to say, let's just set a simple on handler, and we're going to use our UUID. So we've created a kind of a one-off, unique handler here, and I'm going to use this lambda. So I'm going to say, handle a person coming back, a person event coming back here. Let's log by, and since we're getting our reply in here, let's go ahead and accept that value into the deferred, which will send it into our promise. Right? One thing that we do want to do here probably is cancel after use. That's the registration we get back from the Reactor allows us to have it only used one time. So as soon as it gets notified, it'll cancel it and remove it and clean up after itself. So we can do send, we can do notify. In this case, it really doesn't matter. We can use either one. The important part here is that we're sending it to our key, our topic, whatever you want to say. Now, since we are expecting a reply, we'll tell it what key to reply to, and that's our UUID, which just does a simple dot equals change on it. So to actually use this, then in our test, we're going to have it injected because this service is a component. It's found whenever the things are scanned, and so we can inject that in here, and then we can say get a person here from the person service. And now what we've got here from save, remember, is a promise. Now we can set, on success and do it asynchronously if we want to, but we can also just await. We can just block the thread in test, which is really handy. Now await is not, like if you were to do this with a future, await would be forever, but it's not forever here because we can't, in an asynchronous application, we can't afford to have somebody arbitrarily wait, until the end of time for something to happen. So there is a limit on how long you can set it with a system property, but there's always, unless you set it to long.max value, going to be a limit to how long you can wait on a future promise to complete. So just to make sure, I think I got everything, because last time I was missing this call to write value string, and it didn't. The demo didn't work. So let's see if we can get any closer this time. Okay, so here's what we've got. Spring Boot banner showing us that we're coming into Spring Boot, and here we can see the Couchbase stuff start firing up, connecting to our local service. And here we can see we got our reply back. And then if we jump over to our Couchbase console, we should see our document. And there is our document that was saved into the database because it was sent a message to do so through our Reactor, which here we've abstracted out and used the @selector. So that's a fairly simple way to get a lot of functionality. Now you can do the same thing as using the annotations directly. If we are maybe not using Spring and we're just creating our reactors manually, in this case we could just say r.on u/store. Right, we can use the helper methods. We can new consumer person, etc. We can do all this manually using the API if we want to, and that may be the case. Or giving you some options, you can use the annotations, which do the same thing. There's just a component in the application context that looks for any beans that have this selector annotation on it that goes ahead and just kind of does that stuff for you, so that you don't have to do it manually. There's no magic in that. I mean, it's just doing what you would do, but because we know what's happening here, we're doing it for you. Real quick, if we go back, we've got lots of stuff kind of growing up around Reactor. Of course, we've got the TCP stuff, which I mentioned, with the Netty 4, 0MQ to come. The buffer tools, there's a buffer abstraction in there that allows you to do slicing and zero copy stuff, and it allows you to parse data into numbers and whatnot faster than even the JDK parsent implementation. The sequencers for event ordering, in case things are getting out of order, always a possibility in an asynchronous application that maybe events could get out of order. So we've got a sequencer in there that will reorder them. We do some integration with JavaChronicle. Call it a work queue. It's really just a queue implementation. So anything you dump into a queue, and you can use it anywhere a Java util queue would be needed, then it uses JavaChronicle by default. There's various persistence mechanisms you can plug in, but it's just PersistentQueue is all it is. The logback appender is very important if you're doing lots of logging in your application, to have an appender that is asynchronous. There's a couple options out there. Log4j has a RingBuffer-based one. You could use that. This one, the logback appender, is a separate module. It doesn't depend on Reactor. It just uses the RingBuffer directly, but just does asynchronous appending using the RingBuffer, so that you have as low overhead as possible from your logging. Otherwise, you're going to see a huge hit to your throughput, because things are going to be blocking on your appenders waiting to be logged. So it's very important that you keep that in mind. The interface-based proxies, didn't really talk about that. That's kind of a more advanced topic. There's plenty of meat here for other than getting into this, but basically allows you to write an interface and have put a few annotations on it, and have that injected, and then not have to write Reactor code directly. It basically creates a proxy, so that when you call that interface method, it does a notify, and you're able to do the selector stuff. So it's kind of cool, but it's a little more advanced. So there's a Clojure binding by the guys at ClojureWorks, really cool, called Meltdown. Couchbase is working on some cool stuff on their SDK platform. So lots of things kind of growing up around the Reactor framework itself, and that's a good example of driver. Kind of, you could consider the Couchbase kind of SDK platform a driver, if you will, and that Reactor's under that, and then the Meltdown library is a great way to do that on notify pub sub type thing, and then but do it with Clojure's cool language features and things like that. Spring Framework 4, we've got lots of stuff. Reactor is actually used in the Stomp support in the Spring Framework. WebSocket stuff. We've got subscribable channel implementation. We've got various, Spring integration, where you can do syslog inbound, which is what we use in Spring XD. We do some syslog stuff with the Netty support, and we can get 700,000-ish syslog per second. That number, 30,000, is kind of what the regular syslog TCP will do. Other syslog servers we've tested against, like, say, Flume and things like that, and I think it was getting maybe 5,000 to 7,000 versus the 700,000 that we can do in the Reactor syslog. So really, really low latency, high throughput, really efficient stuff there. So Spring XD's got some more advanced stuff. We can do message bus things. We haven't really decided exactly what we're going to do there, but the point is, we can work inside Spring XD as a processor, source sync, however you want to work with it. So that's a good way to deploy as a Spring XD processor module. So, and then our links here. Okay. this is our call to action slide, right? So if you want to go to look at the source code and see, what exactly are you doing here? The wiki's got some good documentation on it while we prepare the projectreactor.org website and have the, updated tutorials and some real slick stuff that our designers came up with. Looks pretty neat. And then the demo code that I showed is there at my GitHub, Reactor Simple. I think a tweet went around earlier with a link to that as well. The Reactor Quick Start is a good, kind of rounded explanation of various components of Reactor. The composables are mentioned in there. We've got some WebSocket example. We can do, there's some Groovy stuff in there that you can look at. So that is not necessarily like a real-world example of how to build a real application, because that's kind of a, what does real world mean? So that's getting you going. Once you get over the hump of the first little bit of, what is a selector and how does this stuff tie together, streams, promises, etc. Once you kind of see, okay, I understand where this is going, the rest of it's relatively easy. So you don't need to see how this fits in, because it will become obvious how to use it. And the rest of it's kind of finesse and how I could use this in this, or I could use it in this. We're not going to cover that with no matter what application we write. We're not going to cover all the different uses that you can do. So it's a little hard to come up with here's a canonical example. Here's how you write a Reactor application, because it's not that kind of a library. It's foundational. That you can write all kinds of things on top of it. So that'll just get you started. And then there is some content on the Spring.io, the new Spring.io website. If you look in there, there's a good Reactor tutorial that they built. It's kind of basic. Getting going on that. If you want to tweet us about anything, if you've got questions or whatever, you can follow us around Twitter and Stefan or myself. We'll try and get right on it. These days we got this stuff on our phone, so we're just just about obligated to answer just about wherever we are. Sitting at a basketball game, watching the kids play, probably we'll be answering your questions. So, speaking of questions, if we do have any that we want to answer, I know it's gone over time a little bit, but if if there's any questions that you want to have answered, we can do that right now.
Excellent. Yeah, there's a number of them queued up. I think we got like 4 or 5. So Oleg asks, is it possible to capture the part of the selector in the consumer?
What you can capture. Well, that's a good question. How do I explain it? When you get notified of a key, that key gets set into the event. So not only can you get the extracted information, like if you're using a URI template, you can get the bits out of it. You can get the whole key as well. So if you're using an object and you're notifying on an object, you can actually get the object that came along with the event. Now, you probably don't want to work with the selector that you used originally to subscribe, because that's on the other side of the equation, if you get my meaning. It's like that's not really, if you want the selector to be variable, then you need to set the data into the selector when you create the subscription, not when you respond to the event, if that makes sense. It's when you're responding to reactions, or being reactive, responding to events, then you can find out what triggered the event, but you probably don't necessarily want to go back to the other direction and kind of manipulate how the selector works based on what events have come in. There's ways to do that, but that's just in general. That's probably a good separation to think about.
Excellent. All right. Rajiv asks, currently we have selectors on the queue. With selectors on queue, the messages don't even make it to the app, so the app is not burdened with unwanted messages. Now with Reactor, I'm thinking that since the selectors are within the app, all messages make it to the app, irrespective about whether the app cares about it or not, so the app is burdened with unwanted messages. Am I correct?
Well, that would depend, I guess, on on how you look at the producer-consumer relationship. Certainly, if you just take the default and you just create an object selector and put a consumer on there and you just indiscriminately publish events, then but that's kind of what it's meant to do. It's not really, the producer-consumer relationship is, it's kind of means different things to different people. So some people want, like say back off, right? If you don't want to publish too many, or you don't want to publish ones that you're not concerned with. There's various things that go into that, and it's kind of specific to your domain problem. So we don't make an opinion about how you want to deal with that. The idea of Reactor is to allow you to publish as fast as possible, as much as you want. Now, that may not be exactly what you want, because, be careful what you ask for, right? Because you just might get it. So, production of events can be, but that's going to be a problem with it, with whatever mechanism you're using. That's kind of why we put in some of these other abstractions that, it doesn't, at first blush, it's kind of like, well, what does that have to do with it? But the persistent queue is a good example. Really, when we're thinking about the producer-consumer problem, I'm really thinking, okay, the persistent queue probably is the direction to go to be the traffic cop, if you will. Certainly, if you're using JavaChronicle, it's going to be plenty fast. It's a super high-speed messaging framework, and you could basically dump things in there indiscriminately if you want, but just as long as you got disk space. And then you can publish those out from the other side, and you can have some control over, what comes, what goes where, and there's some abstractions that we provide that you can do that with, but that's not, an opinion about how that relationship should work is not baked into the framework.
Cool. Let's see. Glenn Lingle asks, is Reactor meant to be used in place of an event bus or a JMS? Or is it just meant to be used within a single app? Furthermore, can it also be used to dispatch events between multiple JVM instances? Not the first time we've heard this question. Interesting.
Oh, yeah, it's a very common question, and it's something that we still talk about ourselves. I don't think we, within internally, we've even decided how this should work. But the basic answer is you can tie multiple processes together, multiple JVMs or whatever. Reactor core is probably not ever going to have like an opinionated way to do that, because different topologies and different availability and AWS versus running local. There's all these questions that come up, right? That just have to be specific to your application. So it's hard for Reactor core to be generic and solve a lot of problems with kind of generic interfaces, and then turn around and be opinionated about a certain way to do it. So it is. I wouldn't say it's replacement of, like, say, a JMS or a RabbitMQ or Redis at message bus or something like that. I would say it is a synergistic with that. In other words, the message bus is the transport. The Reactor is the way that is the client, if you will. Reactor is how messages are dealt with internally in an application, and then what you do with that event, like when a consumer gets an event, does it act on it? Does it decide to, hey, dump it into a queue somewhere so that somebody else can act on it? I mean, that's kind of dependent on your domain problem. So we don't make an opinion about that as far as the core of Reactor goes. We hopefully provide you the tools so that, if there's something that there's common that everybody's asking for, and one of the things I kind of from the very beginning was, just kind of a pet thing that I would like to see is a Dynamo ring style setup, that's kind of a separate optional module that's built on Reactor and would allow you to connect things together. We're kind of working on the 0MQ TCP support. That'd be pretty cool to have that stuff connected together. Again, all optional, all additional components, but dependent on how we want to solve these problems, and not part of Reactor core. But still, even though it's not part of the core, it's it's on a continuum, if you will. It's not like all of a sudden we stop using Reactor and we go somewhere else. No, we're on a continuum. We're dealing with messages internally, and at some point we decide to promote that event off of the JVM. And so the method that we use to promote that is maybe a message queue or maybe a HTTP post or something like that. In another JVM, we decide to promote off of the the queue back into the system and then deal with it locally. So it's just on a continuum. There's no hard, fast lines, rules, etc. about how this should be done because it depends on your problem.
Okay. I think we've only got 2 more questions, Jon. Let's see. Oleg again asks, can one combine multiple selectors, especially for matching performance improvements?
Yes, that's
sorry. Actually, scratch that. I apologize. Glenn, whose question you previously answered about, is it Reactor meant to be in place of an event bus or JMS? He also said, could Reactor be used to implement an event bus? And I think you kind of answered that, unless you feel like you want to add more to it.
Definitely. You could implement your own event bus and do whatever. I mean, that's basically what it is, right? I mean, we just don't use that term. Every reactor is its own event bus, basically. That's definitely doable. So.
Cool. Okay. Last question, then I think we'll close it out. Oleg asks, can one combine multiple selectors, especially for matching performance improvements?
That's a good question. The short answer is sure. And how you do that maybe is the bigger question. Like, probably in that case, I would think maybe a predicate selector would be a better choice, and you'd have a special predicate, that accepted the, let's say a buffer. You're creating, you're reading data in. You don't want to turn it to string. You don't want to take any performance hits on anything if you don't have to. You want to interrogate the first couple bytes, and it's got flags in it or something like that. Well, you would basically just create a predicate selector that accepted your buffer, and then looked in certain slots for certain data and decided, does this match or not? And so that's probably like the simplest way to go about it. And then you could, make that as complicated as you want. Whether you wanted to, introduce, time of day or, whatever other criteria you wanted, that would certainly be the easiest way to do that. There isn't really like and this probably wouldn't be that difficult to create, but like a delegate selector that just basically kind of aggregated, a certain number of selectors together, and the first one to say no gets bailed out. That wouldn't be probably 15 minutes worth to write, a little helper like that. So. Thanks for attending.